questions from homeworks? At this point, we've assigned like 1 through 15. Does anyone have questions from homework? At this point, we've assigned 1 through 15. Going once. Going twice. And no more questions for today. All right. Today, we're going to continue talking about solving these non-right triangles. And finally, we're going to talk about the law of cosines. Hi, Abby. So, if you guys remember, what situations do we use the law of cosines?
Side angle side.
Side angle side and side side side. Those are the two situations for law of cosines. More like s. So let's give you the equation here. We're not going to prove it. It's actually kind of a time-consuming proof, and I don't think it's going to add much to your understanding. So here's our triangle. We've named the angles ABC and named the opposite sides with the corresponding lowercase letter, as is our naming convention. So our law of cosine says that a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. Now, there's nothing special about a squared, right? Could we have done this with b instead of a? Sure, right? Everywhere where there's a b or an a, I'll just trade out for a b and likewise. And if I can do that for b, I can do it for C. So everywhere I had a B, I'll just trade out and put a C. So it doesn't really matter, right, which one you're going to use. The thing to take away here, or that you want to be aware of, is that the side you're solving for has to match up with the angle and the cosine, right? So if you're solving for side A, you need to use angle A. If you're solving for side B, you need to use angle B, etc. The other pieces just fill in, right? Does it matter whether I wrote c squared plus a squared or a squared plus c squared? It means the same thing, right? If I did a times c or c times a, does it matter? Means the same thing, right? So it doesn't even matter really like what you're calling these. It just, you're picking side angle, side or the angle and the side opposite it, and then the other two sides fill in the other spots. So let's do some examples here. So first example, we're going to solve the triangle with angle A of equal to 34 degrees, side B equal to 14, and side C equal to 17. I'm going to start by drawing and labeling a picture. And again, I don't ever worry, you know, like all my triangles look exactly the same. I don't worry about scale. So there's my drawn and labeled picture. Now add in the values. So far, so good. Now what I want to do is determine what type of triangle I have. So I'm given angle A, side C, and side B. What do we have here? It's the side angle side situation, right? Okay. In the side angle side situation, we want to find the missing side first. So in that case, it is side A. So I'm going to be using the law of cosines. That looks like this. And I'm just going to fill in my values for side B, side C, and angle A. So far, so good. Now, how do we get just A? I have A squared here. How do I get just side A? Yeah, we'll square root both sides. That's correct. And at this point, it's calculator time. So I'll just pop up my handy dandy calculator and type this in. What should I check before I press enter here? Yeah, I should make sure I'm in degree mode. It's been a couple weeks since I fired up the old calculator here. I am, so I'm just going to go ahead and press enter. So I get about 9.51. Everybody feel okay to there? Now, important distinction here. Up until this point, the order that we solved our triangle, didn't really matter. Does now. For the law of cosines problems, the order in which you find the angles matters. For a side angle side, we need to now find the smaller angle. So, Mr. Kulik, though, how do I know, if I don't know what the angle is, how do I know whether angle B or angle C is smaller, bigger or smaller than the other one? How can I tell? Great, so the bigger angle will be across from the bigger side. So which one is the smaller angle, B or C? B, because 14 is less than 17. Side B is less than side C. So we're going to use the law of sines to do this. Now, I'm going to pause here for a moment and explain why this order matters. Okay, so I'm going to go back up to my picture and explain to you why the order matters. So we are using side A, angle A, and side B. What type of situation is that? That's the SSA situation, right? What can happen in the SSA situation? You can get ambiguous case, right? You can get that 0, 1, or 2 triangle thing happening. If we choose to solve our triangle in the order that I'm describing, you avoid the possibility of getting anything other than one triangle, and the answer you get is the answer you want. Requires no further investigation. If you choose to not follow the order of solving that I'm giving you, you very likely can run into an ambiguous case where the first answer you get is not the answer you actually want. Ugh. What should we do? I don't want to mess with ambiguous cases. I'm just going to remember the order in which I have to solve the parts. And then I can just plow through this all willy-nilly, just using the correct order. And I don't have to worry about ambiguous cases coming up. Is everybody okay with that? So that's why all of a sudden the order matters, is because we want to avoid that. All right, so we have this equation. What's this kind of an equation called? A what?
Oh, gospel.
Well, yes, that's what we're going to use to solve it. What's it? It's called a proportion. And to solve a proportion, we cross multiply. Between the two of you guys, you had it. Okay. And then we're looking for angle B. What do I have to do to both sides of this equation to get the angle B by itself? Divide by what? 9.5, 1. That's a 1 there, but you said 7, I thought. But, you know, tomato, tomato. I have messy penmanship. We'll blame it on that. Okay? And then how do I get the angle B out from inside that sign? Sine inverse. Very good. So angle B should be then the sine inverse of and now it's calculator time, right? Now, I'm going to make a suggestion to you guys on this. When you're doing these law of sines, you're always going to be using a previous answer. I would be careful on my calculator to make sure that I'm using like the ants command or copying and pasting the full decimal. So I'm going to do second and ants, so I copy the entire decimal for this 9.5. So I get about 55.44. Okay, and then how are we going to find angle C? Yeah, so I know I have 2 of the 3 angles, right? So once again, calculator time. I have 180. I know my angle A was 34. That was given to me. And then I'm going to use the answer, my previous answer. So again, I'm going to use that ants command on my calculator. And I get about 90.56. How do we feel on that? No big deal, right? It's basically the same process that we've been using before. if I was okay there, I should be okay here. The only thing you have to remember is that the order that you're solving for these angles, it matters. You got to find the smaller of the two angles at that side angle side step. Is everybody okay with that? All right, let's do a side, side, side example and get out of Dodge. How's that sound? All right. So let's say we want to solve the triangle with side P equal to 5, side Q equal to 8, and side R equal to 10. Well, I'm going to start by drawing and labeling my triangle. So far, so good. What kind of triangle do I have here? Side, side, side. So that's telling you the law of cosines is the necessary tool to use. However, there is an additional step on the law of sines problem that we must do before we start applying the law of cosines. I can't give you any three numbers and guarantee you can actually make a triangle out of those sides. So we do have a check we need to do to make sure that a triangle is even possible with the side lengths that are given. So the check is easy. It's just that leg plus leg has to be greater than the hypotenuse. If that is true, a triangle is possible. We can continue as planned. If it's not true, you're done, right? If leg plus leg equals hypotenuse, there's no answer. You're done. You say no solution. No triangle possible. If leg plus leg is less than hypotenuse, you're done. No solution. No triangle possible. Everybody's good? So we do need to check this at first because I guarantee you Mr. Kulik's going to sneak in some like impossible problems on you. All right. So the question is, Mr. Kulik, how do I know which leg is or which side is the hypotenuse? 5, 8, or 10? It's the longest one. It's the 10. It's the biggest number, right? Okay, does it matter which leg is which? No. Is 5 plus 8 greater than 10? Yup. So I'll proceed. Everybody's okay? All right. Again, we're solving for angles here. The order in which I solve for angles matters. Because I'm solving for my first angle now. In the side, side, side case, we want to find the biggest angle first. Okay, which angle is going to be the biggest, P, Q, or R? How did you know that? It's across from the biggest side. Very good. So we're going to write R squared is equal to P squared plus Q squared minus 2PQ cosine angle R. Now, in this problem, we're going to be solving for angle R. And anytime we do a side, side, side problem, we're going to have to solve for the angle. So what I'm going to do here is I'm going to start by just solving this equation with no numbers in it for angle R to create another formula for the law of cosines that I can then use in these side situations to solve for the angle to make my life a little bit simpler rather than having to do this algebra over and over and over again every time I do a side problem. Sound okay? All right. So I'm going to start by trying to get this angle R by itself. So I'll subtract P squared and Q squared from both sides. So far, so good. Now I need to get rid of that coefficient in front of the cosine. So I'll divide both sides by negative 2pq. And then my final step would be to do the cosine inverse of both sides to get that angle R by itself. I'm just going to change the order and write angle R first here. Everybody see that I just reflected the equal sign is all I did there. Now, little thing here. I hate that as just like a person that's going to use a formula there. What I would do is I'm going to push that negative sign up into the numerator. When it does that, it makes the R negative, the P positive, and the Q positive. And I would actually think about it this way, just because there's less negative signs in there for me to muck up later on. That feel okay to you guys? Now this formula that we've written is still the law of cosines. It's just been rearranged so that the angle is by itself. I can use this formula now in any side problem to solve for my angle, right? Is everybody cool? Where again, what is the parts that matter here for us? You know, that the angle we want to solve, and that's the side opposite it, is the only two things where it matters where you're plugging them in. The other is just the other two sides, right? The P and Q are just the other two sides. Okay, so let's go ahead and do that then. So angle R is going to be cosine inverse of 5 squared plus 8 squared minus 10 squared over 2 times 5 times 8. Now, real important when you're typing this into your calculator, you definitely want to use that horizontal fraction bar. So alpha y equals. Because if you don't, it's like parentheses city to get that to come out right. And I would rather not have to worry about like all the parentheses in my calculator. I just want to be able to type it in my calculator like it looks like on my sheet of paper. You know what I mean, guys? Massively simpler that way. So that comes out to be about 97.90. Up here too. So now if I look, this is like the SSA or SAS case where I've solved for that opposite side. So when I have two angles remaining, it's like that SAS case where I've already solved for the opposite side. What angle do I find first in the SAS case? The bigger or the smaller? The smaller. Guess what I'm going to do here? Same thing. And again, why am I doing these? Why does order matter here? It's just to avoid the possibility of like running into an ambiguous case and having to sort through that mess. If I do the order I'm describing, if I solve for the angles in the order I'm describing here, we avoid any ambiguous case nonsense and we can plow straight ahead as long as we're going in this order. If you don't go in this order, sometimes it might work out fine. It might not be an ambiguous case problem that has two triangles, but sometimes it might. And when it does, the angle you find is not going to be the angle you need first. So it's like just easier to remember the order. Okay. So we can say that sine of 97.90, that's angle R, over 10 is equal to sine of, the smaller angle was P, because side P was the smaller of the two sides. So we take our proportion, and to solve that, we cross multiply. And we divide by 10. I need to stop writing example problems that have 5 times sine in it because it looks like SS when I write it. And we'll do sine inverse. And so there we go. Oops. Sine inverse. 5 times sine of, and I'm going to use that answer button on my calculator, and then divide by 10. So that gives me 26.69, or I'm sorry, 29.69. But I still have one more angle to go. How am I going to solve for angle Q? Yeah, just do the subtraction. So that's going to be angle R minus angle P. So let's see. Oops. Oh boy. Stay over there like I asked you to. So minus angle R minus angle P. So 52.41 or thereabouts. What do you guys say to that? Pretty okay, right? No big deal. Not super complicated. Every problem's ostensibly the same, which is cool. Once I got the process, it should be smooth sailing. That's where we're stopping here for today. So on to your problem set, we're going to add 15 to 22. So for Sunday, we had 5 through 14 from last time. I'm going to give you 15 to 22 new this time. Now I want to make a warning for you guys about 15 through 22. These are not all law of cosines problems. They're all mixed together now. You're going to have some law of sines problems. You're going to have some ambiguous case problems. You're going to have law of cosine problems all mixed together. So you're going to have to sort those out as your first step of figuring out which one to do. Okay? In addition to that, I have a delta math for you. Just solving law of sines and law of cosines problems. The good news is for the delta math, they don't ask you to solve the whole triangle. They just ask for one part of it. Now, it's possible that solving for one part might involve solving for more than one thing first, right? Like if we had the previous problem and we wanted like angle Q to start. Well, because it's the middle angle, it has to be the last thing that I find, so it requires me actually to find everything before it. I didn't go through super close and look at the problems to see if they have you do that on occasion. I just noted that it's like, okay, you're just looking for one thing. So that's going to be the set for Sundays. You're going to have the 5 through 14 from before break that we didn't check yet. This new 15 to 22, and then the delta math. Next time we'll finish up chapter 7. That problem set will be for the following Sunday. And then next week I'll give you guys your exam review packets and let you guys start working on those. Now remember, the exam review packet is a pretty good deal. If you finish the exam review packet and you turn it in before the last day of classes, I give you 5 points of extra credit on your exam, and you can use your review on your exam. So should you do a good job on that? Should you show really complete work and like explain how you did things so that it would be useful to you later on? Definitely. Mr. Kulik, I'm seeing a lot of upside. What's the catch here? Here's the catch. I don't give you the key until that 2:45, that last day of classes. So you have to do it on your own with no key. Now, like anything like this, I would suggest you take a picture of your review before you turn it in. So like when you do get a chance to look at the key, you're like, oh no, I blew number 4. Better make sure I really know how to do that, because what I wrote down on here isn't going to be real helpful to me. But that's kind of the rest of the year. We do have one other thing in chapter 7 still that we haven't done yet that we always do. What do we still need to do for chapter 7?
Not today.
Not today. There's not enough time left today.
We gotta get that homework quiz.
We got to get that homework quiz, though. When would be a good day for that, you think?
Next class.
Yeah, next class might be a good day for that. I'd be up to snuff on solving triangles with law of sines and cosines. That's really all we've done so far. Would I give you the formulas? Yes. What do you say? Feel pretty good? So that's it for the rest of the semester. You have 2 more problem sets, a delta math, a homework quiz, and the exam. Ain't too shabby. One other thing. Before we left for Thanksgiving break, I asked you guys all to do something, and like 3 of you did it. Joey was one of them.
It was the thing online.
It was the thing online where I asked you to fill out the survey.
I couldn't find the survey.
It's under the announcements at the very, very bottom of our minor Dame page.
I must have missed it.
Yep. So if you haven't done that yet, please fill that out and indicate whether you'd like to retake a test capped at 85 or take a doubled high test score. Okay. If you are retaking a test, keep in mind when you're going to do that. Okay.
What do you mean by take a double?
So I enter another test grade at your highest test score.
Yeah,
So it becomes a 5th test at your highest score. Or you can choose to retake something. The max score on a retake is 85. Okay. Usually there's not a ton of difference between the 2 of them. Huh? What did you
Where's
say?
that survey of minor?
It's at the very bottom under the announcements.
Okay.
Okay. That's it for me. That's basically the end of the semester for us. Anybody with questions on any of that stuff? So next time we'll do the homework quiz and we'll finish up the last set of topics. It's doing area of these non-right triangles. If you have a right triangle, it's just 1/2 base times height because the legs are the base and the height. If you don't have a right triangle, the side lengths are not the height. And it could be really difficult trying to use that formula. We have two others that we can use that are often going to be easier if you're not given a height. But that's next time. I'm done talking here. You guys can take the remaining 15 or so minutes to start on your homework or fill out your survey or whatever.